Welcome to JavaFx. First of all, let us define what is JavaFx. JavaFx is a media graphics framework in creating GUIs which is designed to provide Java developers with a new lightweight, high-performance graphics platform. The intention is for new applications to use JavaFx rather than swing to build the application's graphical user interface. With JavaFx, you can build many types of applications. Typically, they are network-aware applications that are deployed across multiple platforms and display information in a high-performance modern user interface that features audio, video, graphics, and animation. JavaFx has three major components, namely, stage, scene, node. First is the stage or the window. Is a top-level container that hosts a scene, which consists of visual elements. It is represented by stage class of the package JavaFx.stage. The primary stage is created by the platform itself. A stage has two parameters determining its position, namely width and height. It is divided as content area and decorations. Second is the scene. A scene represents the physical contents of a JavaFx application. It contains all the contents of a scene graph. The class scene of the package JavaFx.scene represents the scene object. At an instance, the scene object is added to only one stage. You can create a scene by instantiating the scene class. You can opt for the size of the scene by passing its dimensions, height and width along with the root node to its constructor. A scene graph is a tree-like data structure hierarchical representing the contents of a scene. In contrast, a node is a visual graphical object of a scene graph. Node. All components attached to the scene graph are called nodes. All nodes are subclasses of a JavaFx class called JavaFx.scene. There are three types of node. First is the root node, the first scene graph. Second, branch or parent node, the node with child nodes. The abstract class named parent of the package JavaFx.scene is the base class of all the parent nodes, and those parent nodes will be of the following types. Group, a collective node that contains a list of children nodes. Whenever the group node is rendered, all its child nodes are rendered in order. Any transformation, effect state applied on the group will be applied to all the child nodes. Region. It is the base class of all the JavaFX node-based UI controls, such as chart, pane and control. Web view. This node manages the web engine and displays its contents. The third type of node is the leaf node. The node without child node, for example, rectangle, ellipse, box, image view, media view are examples of leaf nodes. It is mandatory to pass the root node to the scene graph. If the group is passed as root, all the nodes will be clipped to the scene and any alteration in the size of the scene will not affect the layout of the scene. To fully benefit from JavaFX, it is useful to understand how JavaFX is designed. JavaFX provides several predefined layouts that are represented by a class, and all these classes belongs to the package JavaFx.scene.layout. HBox. The HBox layout arranges all the nodes in our application in a single horizontal row. BBox. The BBox layout arranges all the nodes in our application in a single vertical column. Both classes have three properties and two methods. These are the following. Alignment. This property represents the alignment of the nodes in the bounds of the VBox or HBox. You can set value to this property using the setter method setAlignment. Fill height. This property is of Boolean type, and on setting this to true, the resizable nodes in the VBox or HBox are resized to the height of the VBox or HBox. You can set value to this property using the setter method setFillHeight. Spacing. This property is of double type and it represents the space between the children of the B box or H box. You can set value to this property using the setter method set spacing. Set hGrow sets the horizontal or vertical grow priority for the child when contained by an H box or B box. This method accepts a node and a priority value. Set margin. Using this method, you can set margins to the H box or B box. This method accepts a node and an object of the insets class, a set of inside offsets for the foreside of a rectangular area. Border pane. The border pane layout arranges the nodes in our application in top, left, right, bottom and center positions. This class contains 5 properties. Bottom. This property is of node type and it represents the node placed at the bottom of the border pane. You can set value to this property using the setter method set bottom. Center. This property is of node type and it represents the node placed at the center of the border pane. You can set value to this property using the setter method set center. Left. This property is of node type and it represents the node placed at the left of the border pane. You can set value to this property using the setter method set left. Right. This property is of node type and it represents the node placed at the right of the border pane. You can set value to this property using the setter method set right. Top. This property is of node type and it represents the node placed at the top of the border pane. You can set value to this property using the setter method setup. Stack pane. The stack pane layout arranges the nodes in our application on top of another just like in a stack. The node added first is placed at the bottom of the stack and the next node is placed on top of it. This class also provides a method named setMargin. This method is used to set margin for the node within the stack pane. Anchor pane. The anchor pane layout anchors the nodes in our application at a particular distance from the pane. This class provides 4 methods that need to pass a double value representing the anchor. Set bottom anchor, set top anchor, set left anchor, set right anchor. Tile pane. The tile pane layout adds all the nodes of our application in the form of uniformly sized tiles. This class contains 10 properties. H-gap. This property is of the type double and it represents the horizontal gap between each tile in a row. B-gap. This property is of the type double and it represents the vertical gap between each tile in a row. Orientation. This property represents the orientation of tiles in a row. Craft columns. This property is of double type and it represents the preferred number of columns for a horizontal tile pane. Craft rows. This property is of double type and it represents the preferred number of rows for a vertical tile pane. Craft tile height. This property is of double type and it represents the preferred height of each tile. Craft tile width. This property is of double type and it represents the preferred width of each tile. Tile height. This property is of double type and it represents the actual height of each tile. Tile width. This property is of double type and it represents the actual width of each tile. Tile alignment. This property is of double type and it represents the default alignment of each child within its tile. Grid pane. The grid pane layout arranges the nodes in our application as a grid of rows and columns. This layout comes handy while creating forms using JavaFx. This class contains 3 properties. H-gap. This property is of the type double and it represents the horizontal gap between columns. B-gap. This property is of the type double and it represents the vertical gap between rows. Grid lines visible. This property is of Boolean type. On true, the lines of the pane are set to be visible. Flow pane. The flow pane layout wraps all the nodes in a flow. A horizontal flow pane wraps the elements of the pane at its height, while a vertical flow pane wraps the elements at its width. Column H alignment. This property represents the horizontal alignments of nodes in a vertical flow pane. Row B alignment. This property represents the vertical alignment of nodes in a horizontal flow pane. H gap. This property is of double type and it represents the horizontal gap between the rows columns of a flow pane. Orientation. This property represents the orientation of a flow pane. V gap. This property is of double type and it represents the vertical gap between the rows columns of a flow pane. Those are some of the layouts that you can use to create an interface. Now, let's have a sneak peek on how to create a simple interface using JavaFx. So these are the necessary things that you have to import for JavaFx. Scenes, layout types, nodes and styles that you can use in making the interface using JavaFx. So you have to extend your class like what we did here, so it can run as an application. You need to create a start method and use it to run the application. Afterwards, you can now declare and initialize nodes such as button text and text fields. Text fields is a type of node wherein users are able to input. You can also be able to manipulate its position, style and layout. There are a lot of classes and methods that you may use where you can edit the design of your interface. The style that we are using here is the general layout, which is the pane. After making the layouts, nodes and other elements that you declared, you have to place it inside the scene with its measurement. In that way, the system can determine the size of the application since the scene is part of the stage, and so the stage will adjust with the size of the scene. You can incorporate different layouts and stack it or overlay it with one another resulting to a different output rather than using a single layout. Layout examples are pane, stack pane, grid pane, region, group pane, V box, vertical box, H box, horizontal box, and many more. Found in this method is the code that whenever the user press that button, it will execute all the commands inside the block. The reference variable that we used to represent our stage is the primary stage, which is the format to incorporate the scene that you made composing of layout and the size of the scene. The stage is composed of the scene. Lastly, you can display the stage by using this method. This will launch the extended class that will run as application.